checking if adjacent values are in a Numpy matrix. So, I am currently trying to figure out a more optimal solution to determine connected components in an image. Currently, I have an array with coordinates that have certain values. I want to create groups of these coordinates based on if they are touching. I am using a Numpy array, and currently I have to check if each value, top left, top middle, top right, middle left, middle right, bottom left, bottom middle, bottom right, is in that array. I do so via this code. However, this clearly takes a significant amount of time if the image is large. I had the idea to just create an Boolean matrix with dimensions of the width and height of the image, and then assign the value true to values in the matrix which correspond to pixels in the image. The image is black-white. I was wondering, is it possible to, instead of having to check each value like that, determine if there are elements labeled true directly surrounding another true value? This is what the input array would look like. The output would look like. The function I am hoping to refine would check if the true values are touching, and create a network of all values touching. It would keep running with the new values found.
Approach number 1. We could get the Euclidean distances and see if any of the distances is within sqrt2, which would cover up down with distance equals 1 and diagonal with distance equals sqrt2. This would give us a mask, which when indexed into the group coordinates array would give us the connected ones from it. Thus, an implementation using SciPy's for getting those Euclidean distances, would be sample run. Approach number 2. Another way would be checking with absolute element-wise differences between the first columns of the two arrays and similarly for the second columns. Finally, get a joint mask from these two masks and checking any match and indexing again into group array for the filtered coordinates. Thus, implementation for such a method would be approach number 3. Another approach, and probably would be better if you have R as a Boolean array instead of as a two-column coordinates array. The idea is to dilate this Boolean array of R and then see which coordinates from group coords would also lie in this dilated image. For the dilation, we would use a 3x3 kernel of all ones to cover all of those neighborhood places. For detecting those common points, we need to draw an image with those group coords. Thus, the code would be sample run.
Depending on the ultimate goal of your code, you might find scipy.image.label and its relatives useful. For example, Label returns two values. The first is an array with the same size as the input array. Each distinct connected component in the input is assigned an integer value, starting at 1. The background is 0. The second return value is the number of components found. In the following, where labeled _array equals I, returns a tuple containing two arrays. These arrays are the row and column indices, resp, of the connected components. You can zip those together to convert them to lists of row, col, pairs.
If you want to support the channel, please consider subscribing.